Section 8.1 Inequalities Day One Part 3 has the first checkpoint for Part B, and it has the vocabulary preceding Part C.
Now you should be on the back of your notes for Section B, and this is called checking solutions. So what we're going to do, our direction says, tell whether -4 is a solution for that inequality. So your final answer is going to be either yes, -4 is a solution, or no, -4 is not a solution. So to do that, we have to see if -4 makes my mathematical inequality true. Now we're not saying balanced anymore because it's not balanced. One side is heavier than the other, or one side is less than the other because we're comparing. So we just want to make sure that it makes the inequality true. So we're going to plug -4 in for our variable term, and we're going to simplify the process to see if it stays in that correct comparison. So I'm going to substitute. So instead of x, I'm going to write -4 plus 8 is less than -3. And since I have an operation I can simplify on the left side of this inequality, -4 plus 8 is 4, is less than or equal to -3. So now that the left side and the right side of the inequality is simplified, can't go anymore, I have to check the comparison. Is it true? Did -4, when I substituted it in, make this inequality a true statement? So is 4 less than -3? And hopefully you're saying no, 4 is actually greater than -3. So this is not true. So we can say no, -4 is not a solution for this inequality because it didn't make the inequality true in the end after simplification. We're going to do B. -4½ times x is greater than -21. So I'm going to take -4½ and it's being multiplied by x. So I'm going to multiply it by -4 is greater than -21. I just substituted that value in. Remember, if your value is negative, make sure when you substitute it goes in parentheses so you don't lose operation. So I have a negative times a negative, which is going to give me a positive, but I have 4½ times 4. So some of you might just be doing your side multiplication. 5 times 4 is 20, 4 times 4 is 16, plus 2 more is 18. One digit after the decimal, one digit after the decimal. So -4½ times -4 turns out to be positive, because of negative times a negative, positive 18 is greater than -21. Is that true? Did -4 make this inequality true? Is 18 greater than -21? And hopefully you're saying to yourself, yes it is. So since this is true, I can say yes. -4 is a solution for the inequality. So that's what I'm checking. Again, I'm checking to make sure that -4 not balances, but satisfies the inequality. So again, you have to move away from the balance idea of an equation in saying, does this solution make the inequality true? So we're going to move away from that. Here are 3 problems that I want you to try. Tell whether -6 is a solution for those. So you're going to be substituting -6 in for all 3, and you're going to tell me in the end, when simplified, did -6 actually make this inequality true? So I'm going to walk away for a second, give you a couple seconds to pause it so that you can read it off. C plus 4 is less than -1. 5 minus m is less than or equal to 10. Last one, 21 divided by x is greater than or equal to -3½ That's your checkpoint for section B. So the last and final concept for our notes in 8.1 is actually graphing an inequality. How do we show all possible solutions instead of just saying, yes, this one works, no, that one doesn't work, and kind of doing it individual? How do we show them all? So that's the next section for vocabulary, and we have to go over a couple of vocabulary words before moving on. So the blank shows all the solutions of the inequality on a number line. And if you don't remember, we call it a graph. Some of you might remember this from 7th grade. We call it the graph of an inequality. And we actually graph inequalities. And I'm going to show you how to do that in the next presentation. So right now we're just going to go over vocabulary, and then I'll show you how to do it. So there's a graph that we're going to have to do for an inequality. So we're going to simplify it. We're going to see if it's true or not true, and then we'll graph those solutions. So a blank is used when a number blank is a solution. I know it sounds weird. And the next one, a blank is used when a number is blank a solution. So, an open circle is used when a number is not a solution. Because it's open, we're not including it. When you include something, you shade it in on a circle. But we're not, so we're just saying this is not a solution. And then we have a closed circle. So when we close that circle, we're including that number. Is used when a number is a solution. So again, open circle, not a solution. Closed circle is a solution. You're including it. So once we have placed our circles, open or closed, we actually shade a region, and we use an arrow to do that. An arrow to the left or to the right shows that the graph continues in that direction. So what we're going to do is we're going to have to set up a number line, and we're going to have, let's say, a number. There's going to be placed, let's say this is 4, just make one up. There's going to be an open circle, like this, or there'll be a closed circle. So that's the difference between an open and a closed. The closed is shaded in, the open does not have shading. Okay? So that's at 4, there's an open circle. And then we're going to shade. And what I mean by shade, we draw an arrow that it's shaded everything to the left in that direction is included. But if it's not to the left, we can start at that circle, open or closed, and shade all the way to the right. So all the solutions go in that direction. And the graph continues in that direction. That's why there's arrows. I can't show it, but I can show it goes on forever by using arrows. So now we're going to graph our solutions using open or closed circles, and then we're going to be able to shade left or shade right from that circle. Some of you might remember this a little bit. If not, no worries. We're going to go right back into a review next.